Hello everyone, welcome to Better Tech. So today we have Mike with us from Timescale. Mike, welcome to Better Tech.
Thanks for having me.
Sure. So before we get started, can you give a quick introduction about yourself?
Sure. I'm the co-founder and CTO at Timescale. Timescale is a roughly five-year-old company that builds a time series database and the cloud that offers it. And I'm sure we'll talk more about that. I have a kind of a long background in distributed systems, storage systems, databases. Beyond Timescale, beyond being an entrepreneur, I'm actually also an academic. I'm also a professor of computer science at Princeton, where I've been on the faculty for about 15 years now.
Mm-hmm. That sounds great. So, Mike, how did your career make a progression? How do you get started? Then, about your education, then doing sort of various roles or maybe starting various companies. Can you give a brief of that?
Yeah. So, I think, one thing I've always liked to do even from the beginning was I always wanted to build things that people use. And, even when, I said I kind of a academic, if you look back at the work I always did there, it was about kind of building distributed systems and running kind of open source, deploying them. In fact, I kind of first started my career in the early 2000s at the same time all the work on peer-to-peer was starting to come out. And so I was very involved with the first kind of peer-to-peer systems. It was, the idea was this was before cloud. And it was the idea that it was like kind of democratizing access to computing power. Many of the things that we sometimes hear about crypto now, but not with such financial incentives back then. And so for example, I worked on some kind of open source peer-to-peer content delivery networks. I first actually deployed one in 2004. I ran it. It was running on for about 10 years. If you go to Slashdot which is no longer a thing, that's the pre-Hacker News. But if you go to Slashdot, a lot of times people were using it to like cache content because we didn't have these clouds and all these technologies back then where it was easy to cache content for free. That would get a couple million users a day. From that, I went into a lot of things around internet architecture. This was through my research career. I spent time at NYU and then Stanford. Actually, as part of it, one of the technologies that we developed, myself and another entrepreneur, Martin Casado, formed a small company around IP geolocation that was acquired by another company which became Newstar. And I was also very involved with the work that became software-defined networking. So if any of your readers are familiar with OpenFlow or software-defined networking, we were, again, looking at the ways how to enable developers. It was a lot of times about developers, how to enable developers to use content delivery, how to enable developers to use programmable networks. And so I was very involved with that work. And, after working at Princeton, I started getting much more involved with cloud architectures, distributed systems around geo-distributed services. And that kind of led to what ultimately became the kernel of Timescale.
Mm-hmm. So, you also have done a PhD in computer science. So, what was your topic of research? You mentioned distributed systems, but was it also the same topic on which you did your PhD, or was it?
Yeah, the title of my PhD was kind of funny. It was called Democratizing Content Delivery or Distribution, one of those two. And it was related to that system. It was called Coral CDN. It was related to that system about building an open CDN. All of the algorithm, it was deployed at about 1,000 locations worldwide, 1,000 POPs. The algorithms to make that all kind of self-managing to deliver kind of effectively. The idea was like you could point it at any website and it would start basically proxying, kind of like the free Cloudflare, if you will, peer-to-peer Cloudflare.
So, if you would like to suggest like what Timescale DB really is in like a layman term, how would you do that?
So one of the best ways that to developers is I say we help supercharge Postgres. So
All
if you
right.
think about Postgres as this amazing relational database, highly reliable, highly trusted, it's developed for lots of different use cases. And general purpose tools become a little bit of kind of jack of all trades. And so what we do is we're looking at things like analytical data, time series data. The workloads that you need to handle for those are different from the CRUD database that you have sitting behind your web app. And so, you have the same underlying technology that's often used for these both things, but they actually have very different needs because the workload patterns are different. What developers expect from them are different. The performance requirements are different. And so we have built Timescale TimescaleDB is implemented as an extension in Postgres, although we have it's low level, it's written in C, it's hooked throughout the database, but we effectively kind of supercharge it to make it work for analytical workloads, time series workloads, and whatnot.
So, so you touched upon Postgres. Now, Postgres is, as you said, is a relational DB. Now, how would you relate time series data to it? What in general or in easy terms a time series database is?
Yeah. So if you think about, and I like to often think about it as what's the type of data and what do the workloads look like? So if you think about what you're storing in the database, you can imagine two ways to store it. Imagine you're keeping inventory, the simplest thing. Either you keep inventory that says, I have 10 widgets and 5, foobobs. And when somebody buys something, you change the 10 to a 9 and then to 8 in place. Or you want to maintain an order book that says, hey, there's an event that somebody purchased a widget. That representation of my actions as separate events, I think about when they purchase a widget, and you're going to keep a timestamp, right? Mm-hmm. You could also think the same as sensor data. That is, in the first events, was a discrete action that I'm recording in this event. Well, you think about sensor data, it's the stream of constant things I move into the system. And that sensor data could be, IT observability, what my CPU is. It could be IoT data. It could be, geo data. We have people who use us for logistics, where container ships are going, where trucks are going, where trains are going, where satellites are going. We have people using us in space. That's all of what they're recording is information associated with a timestamp. And it allows them not to just look at an instance in time, but it allows them to look at how the system progressed over time. And so often we say that, it's like the difference between an image and a movie. The movie just captures so much more information that it's useful to be able to, sometimes you want a point in time snapshot, but with the right type of time series data, you could do that. You'd have all that historical data that you could understand how your application, product, system, people, whatever, change over time. Now you can say that's now a lot of data, so I need to worry about scale. I need to worry about performance. The importance of that data changes. The importance of the data in the last 5 minutes and 5 years ago is different. So there's lots of architectural decisions that and usability things that arrive from there. But that has limits about recording information and associated with timestamps and looking at how things change over time.
So essentially, you give the analogy of a movie and an image. Certainly that's helpful. Now, this time series data can be very much helpful in making predictions or analyzing or figuring out what the pattern in the data is going to be. Like, for example, in a retail store, we can see what the footfall of customers at a given time. So, for example, are they coming in more in the morning time or in the evening time, or what's the sales time? Is
absolutely. And in fact, we have customers who are exactly the same applications. We have customers who do video analytics to look at traffic patterns. We have customers who actually do not video, but other type of sensor analytics to actually look at retail. Some of that is for counting. We saw some great customers who were using that type of analytics initially to enable retail. And post-COVID, they actually changed their business model to actually look at urban density and building density to help with, how crowded are my physical spaces. So there's a lot of those applications where, and you're right, what time series data allows you to do is We say, understand the past, like analyze the past, understand the present, and predict the future. And without that historical data, you only have a really narrow snapshot in time.
So, I mean, you mentioned that you actually selected Postgres for implementing Timescale. Now, there comes the comparison of an SQL or a relational database to a NoSQL database. So people talk about that in case of time series, there's a whole bunch of data. And maybe for big data applications, NoSQL is a better choice as compared to the SQL one. So what was the core decision-making factor for you to go with a relational DB and specifically Postgres as compared to other open sources like MySQL, for instance?
Sure. So there's a couple questions there. Let me try to take them in order, which is SQL versus NoSQL.
Yeah.
I think there's two things. One is I think the pendulum swings back and forth. People were using SQL databases for decades. Maybe 10 or 15 years ago, people were saying, and the argument was a strange one. The argument wasn't that NoSQL was a better query language. The argument was typically that SQL doesn't scale. We need NoSQL.
Yeah.
And I would say is like, actually, if you look at almost all the systems that said SQL doesn't scale, we need NoSQL, they've now actually built SQL interfaces. And so that comment was actually more about the underlying system architecture and less about the query language itself. Mm-hmm. And what you've seen, there's a whole wave of they're sometimes called new SQL. There's a whole wave of new data technologies. People come to it from a different perspective. We come to it from the angle of analytical workloads, Postgres, kind of supercharging performance. Some other databases come to an angle for reliability, But I think there's a whole wave that people said, no, it's not about the query language. It's about what is the underlying architecture. And yes, maybe we were caught in a rut with Oracle, MySQL, and Postgres had many of the same designs for 30 years, 20 years. And then people started saying, what are other changes we could make, not the query language? I think now if you look, basically every data system has adopted SQL. Even if you think about the data warehousing systems, like you mentioned big data, you could think of the successor of Spark and Databricks. SQL is like is the most popular query language for most of these systems. Mm-hmm. Now, you said a second thing. Why Postgres? We just think it's an amazing platform, highly reliable, highly trusted, great community. And it was kind of a no-brainer to us to choose Postgres if we were going down that alley. And in particular, when you sometimes think of time series data, you only think of here's that record. But what is often very also important is all the information around it. So what we found and what a lot of our users, it's not just the sensor data, not just the order, it's that you also want the relational metadata associated with it. There's an order and, next to it is a SKU, an object ID. Well, you want other relational data around that object ID, or there's a device ID. You want other. So you really want the ability to join directly in your database. I could talk about Timescale in a minute, history that we actually didn't quite start building a database, we're building a platform. And the lack of the ability to join between relational and analytical data was a huge problem with us. And that's actually why we built Postgres. One last thing I want to quickly say is you mentioned big data systems. I think there is fundamentally a different use case between the data warehouse, where you have the centralized repository that you're throwing lots of data in. And then after the fact, there's some data analysts, some data engineers, some data scientists who are doing reporting, machine learning, whatever. That is what a lot of the big data systems came out of. While if you think about a lot of databases and time series and Timescale's use case, it's that we help developers build applications. So they're building customer facing applications. People aren't serving their website off of a Hadoop cluster. They are serving their website and their product and their SaaS app off of Timescale.
All right. Okay. So you also suggested like a few customer use cases in the retail and other industries where customers are actually leveraging timescale DB. So can you give example of like some of the key use cases that these customers are working with? I
Yeah.
mean, what you have seen in your experience working with different clients?
Yeah. So I think, I mean, I mentioned some of those, IoT is a big one. You can think about all the device data, logistics, often for a similar reason, smart manufacturing, smart agriculture, energy and the environment, across a whole, renewables, oil and gas, solar, observability, kind of IT monitoring, fintech and crypto, a lot of, the order book data, the tick data, trade data, monitoring the blockchain. It's all form of time series data. Product analytics, things that you wouldn't necessarily expect. Like we have a number of customers in music or gaming. I like to think, 20 years ago when you want to see who the breakout music stars, you go to the Smoky Club and see what the crowd thinks. Now you monitor Spotify and SoundCloud streaming data. Well, that's time series data and that's analytical data. So, I mean, the way we sometimes like to say is like all, it's a very Gartner-esque phrase about digital transformation. But I do think that basically, all companies are becoming partly digital and data-driven companies. And part of that journey of becoming a data-driven company is you are collecting analytical data to understand it. And maybe the first phase is you throw it in a data lake and you run a report or do some post hoc analysis. The next phase is you start incorporating that into the customer experience and the product experience you are offering. And so that's kind of where we fit in. And that's why, we just have such broad use cases across, almost every industry.
So, I mean, timescale, it's all about time series data that you talk about. So there's a thing which is called like a timescale cloud. So what it is, and where you are hosting these services, is it AWS, it is Azure, or, how does that work? The timescale cloud specifically?
Yeah, so we offer a managed service in all AWS, Azure, and GCP. We made the decision as a company, and especially as a startup, really to try to provide a great customer experience. And well, what company doesn't want to provide a great customer experience? But we do that by we have taken a very specific kind of what you'd call go-to-market decision, which is that, we build Timescale DB. It's open source. It's all on GitHub. You could use it, install it, whatever. But our commercial offering is our managed service. So we don't sell on-premise an enterprise edition. We offer the best software. People could run it, embed into the application, self-manage it. That's all free. But if you want a managed service, if you want not just the managed service of the core database, but basically us rethinking what it means to offer basically a database cloud, what it means to offer an amazing database experience built for the cloud, not that I have my software and I'm going to, have the same software experience in your on-premise data center, in your account, everywhere. That's kind of what we built for in Timescale Cloud. And so it's kind of a fully managed experience, simplifies both kind of application development with a lot of the capabilities that we built in, as well as really simplifies the operational capabilities of what a modern kind of dev team and DB ops team wants. Automated HA and backup and forking and auto scaling and automated kind of tuning and being able to support many databases, dev, test, prod, migration things between different security zones. So all of that things that you want as kind of a robust, reliable database experience.
So in your experience, you have seen the time series databases catching up? Are they becoming popular? More people are adapting it, or you think that still there's quite a bit of gap in terms of the users who want to consume time series data, or they even don't know, or they are not aware if they need time series database or not?
So I think what we've typically seen is the need for it is perhaps even greater than the awareness. And what I mean by that is, if I walk through this use case, like probably a lot of your listeners are like, oh yeah, I've stored this type of data, right? And often what you do is, you turn to what you know. So it's funny, a lot of the people come to Timescale, I mean, maybe they're greenfield that they're starting from scratch, but if they've already used something, they've already used what they're familiar with. They've used a Postgres, maybe a MySQL, maybe a Mongo, right? And it's more like, yeah, I know this database, I'm going to start using it. But it's not designed for this analytical use case. It's not designed for time series data. So it doesn't handle the scale and performance and the ease of even analytical features that we've developed for this type of analytical queries. And so they kind of say, this is now really hard. It's not performance. It's not scaling. So that's when they start also looking for an alternative. And they realize that, hey, I love a relational database. I love Postgres. And this allows me to use the tools I know, not have to worry like this exotic thing I need to retrain myself. I'm not really, developers always know there's gotchas, right? So they're like, well, if I go from Postgres to some like really exotic option, like what is the thing that's going to bite me 6 months from now? And I think the way that we've designed it, especially as part of the whole really just supercharging Postgres, really allays a lot of those concerns and kind of allows them for their next, 10x growth.
So how do you see Timescale catching up? I mean, where do you see the company going in 5 years or 10 years time? I mean, do you see it going on to the same trajectory, or you think that you might pivot or you might expand the product portfolio? What are your thoughts on that?
Yeah, well, I mean, I'm not sure what we're trying to catch up to, but I think you're more broadly asked, like, what do we see the future of Timescale? And, I think the future is really good. I mean, I think that the whole team is excited by the opportunity. I mean, one thing that has constantly been the case that every time you look at the market for data and databases, like the market is way bigger than like people realize. Like, I think it was like when Snowflake went public in their S1, they said the entire total addressable market was X. And within a few years, their market cap was equal to X. So either they own 100% of the market, which is not the case, or it's just a much bigger market than anybody realized. And I think that's the case. And I think the case is that we just see every company is digitizing, become data-driven. And, it's a big opportunity. And I think the big opportunity is to say and we also think, like, again, as a business, we're focusing on, we offer an open source thing that anybody could use, but our business side of it focus on the cloud experience. And we still think the cloud is still in its early days. It's $1 trillion market. And I think it still has so much growth to have. And so, we're building, an amazing experience, allowing people to supercharge Postgres for the cloud. And we think there's just a really big opportunity there.
Sure. So, I mean, before we close, any sort of message that you would like to give out to developers, I mean, developing applications, how do you think they can leverage the time series databases and Timescale in their products? I mean, and how they can sort of consider having time series data into their applications and making the life of end users easier?
Yeah, so I think there's a couple things. It's a great question. Thank you. I think there's a couple things there. One is, one of the reasons you ask us, like, why Postgres? I said we love it, but like, one of the things we like about Postgres, I know it sounds funny, is that I think our announcement blog post when we launched Timescale was when boring is awesome. And what we meant by that is, look, I think we're doing a lot of very cool engineering and building great technology at Timescale. But if you're a developer, like, your job is to build an amazing application. Yeah. It's not to become a database expert or a database engineer to build that application. So I view us as succeeding in both, when you could really turn to Timescale DB, Timescale Cloud, and it just works for you. And, it's boring. It doesn't keep you up at night. You sleep soundly with it. We And that is both reliability, but that's also performance. You know, as your load grows, all of a sudden things don't start slowing down and it stopped working. And so I think that, I mean, a lot of this probably you're nodding because like as you gain more experience, I think that most people get that. But I think that's a real thing. I think developers should, you know, it's a very creative task. They could focus on their applications, you know, pick a database and platform that they trust to grow with them and they understand, you know, that doesn't have that, you know, weird corner case 6 months from now where all of a sudden everything breaks apart and you need to totally re-platform. And I think in the end, like, you know, it's that balance between figuring out how to develop, you know, efficiently and yet do so on sound foundations. And I think we did that when we made our own engineering decisions. And I think that our kind of customers rely on us for that as they build on top of it. Now, in terms of using time series data, I mean, I think if you think about most times your applications, you're probably using a database a lot. And if you're, you know, many of your users probably already are realizing they're storing events, they're storing metrics. That becomes part of their SaaS, particularly if they're SaaS engineers, that becomes like a big part of their SaaS experience. If not, just ask yourself, like, is there important information either that I could use internally, dashboards, whatever, or that my users will like that I'm not currently exposing? And in fact, we could just do this in a data. We could really use capabilities in a great database like Timescale to make this happen.
Sure. So Mike, in the end, thank you very much for your time today. And I mean, enlightening us with your thoughts related to time series data as well as Timescale in general. So I would like to take this opportunity to thank you and also request you to maybe host you some other time as well with another exciting topic, maybe an in-depth analysis of time series and Timescale.
Well, thank you for having me. I enjoyed it.
Thanks, Mike. Have a good one.
Bye-bye.
Bye.